majors. We're going to be doing day 3 and 4 kind of combined together. Um, it's not that difficult to combine it, but we just want to make sure you guys understand what is congruent triangle first before we start trying to identify the different types of triangles. So note day 3 goes over congruent triangles, and by the time we finish this, you'll be able to name and label corresponding parts of congruent triangles. So the corresponding parts of congruent triangles is usually abbreviated as CPCTC. Corresponding parts of congruent triangles, congruency is what, it gets abbreviated. So what this is talking about is when we have two triangles that are congruent, when 3 of their sides and 3 of the angles of one triangle has the same measure of 3 of the side and 3 of an angle of another triangle. It doesn't mean all of them are going to be 5, 5, 5 or 6, 6, 6. It means one side is 5, that means the other side would be 5. If this is 6, this would be 6. If this is 8, this would be 8. That's what it's talking about. And the same thing goes with the angle. So whenever it's labeled that it is congruent, I can say, okay, which one are going to be the corresponding side? BA is going to be congruent to, on the other side is going to be RS, right? And if I go with BC, BC is going to be congruent to ST. And you can see that the three lines are the same. And then if I go over CA, it's going to be congruent to TR or RT, right? On the other side. And the same thing goes with the angle. Angle B is going to be congruent to angle S, right? Because they both have 2 lines. Angle R is going to be congruent to angle, angle A, is congruent to angle R on the other side. And angle C is going to be congruent to angle T on the other side, okay? That shows you which 2 triangles are going to be congruent, and this is called corresponding side and corresponding angles. So when I write the statement, since I knew triangle ABC, A correspond with B, A correspond with R, B correspond with S, C correspond with T. So if I wanted to write the triangle statement, I can say triangle ABC is congruent to triangle A correspond with R, right? R, B correspond with S, and C correspond with T, right? RST. What if we change it and went CAB, like this way? So CAB is going to be congruent to TRS, right? So TRS. What about BCA? BCA. It's going to be STR. Triangle STR. One thing you have to make sure is the corresponding angles. The first A and the first letter here has to be they have to be the corresponding angles. That means they are the one that are going to be congruent. B correspond with the second letter, which is S. C correspond with T. That's why when we're talking about congruent triangles, the corresponding parts are also going to be congruent. Okay, that's what they're talking about. So statement and state the congruent statement in this case. So I'm going to skip for you guys to do number 1. What is ABC congruent to? But I will do number 2 for you, because this is where you also need to be careful because of the common line here, BC, right? So A. So I usually focus on the angle. A is corresponding with what? D, right? So where A is, I'm going to put D. Then B comes next. This B has 2 lines, so C has 2 lines, right? So then I'm going to go C. Then C has 3 lines, this B has 3 lines, so that's what you guys need to do. So triangle ABC is congruent to triangle DCB. Very good. I hope you guys understand what we're doing. So for this example 3, it says find the value of X. So now, given if ABC, triangle ABC is congruent to triangle DEF, right? So that means A is going to have the same measurement as D, So this would be 57. B is going to have the same measure as E. E and B are 90, so that's already given. And C is going to be the same measure as F. Okay, so what you guys can do is, okay, what is this C going to equal to? You're going to 90 minus 57 gives you what, 33, right? Because so this is going to be 33. That makes F equals to 33. So I can just easily say, okay, 6 plus 3 equals to 33, right? So I can do minus 3 from both sides, and I have 6x equals to 30. Divide both sides by 6, x would be 5, right? That's what I can do. And for this part, number 4, you guys can do the same thing. A is congruent to D. A is congruent to D. So D is given to be 102. So I know this is going to be 102, right? B is congruent to E. E is going to be 36. And then C is going to be congruent to F. C is congruent to F. So what is C? I can subtract this from 180, find out what C is, and then make F equals to that piece. Right? So I want you guys to go ahead and do it and solve for X for number 4. So what is it going to be for X? Okay? All right, for properties of congruent triangles, you have to remember congruent triangles are reflexive, they are symmetric, and transitive. And we'll talk more about it when we get into the lesson, what that means. All right, so in the first page, we were talking about how two triangles are congruent, all sides are equal, all angles are equal. But there's a shortcut that we can use to prove triangles are congruent, okay? So this page gives you everything you need. You need, and this is day 4 notes, this is day 5 notes, and then we will talk more about the rest of them in day 6 and 7, okay? So one thing you guys need to remember is if we are saying two triangles are congruent by side, 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 that means the corresponding sides need to be congruent. So I have one side congruent to this side congruent to this side, and the third side is congruent to the third side. Just knowing that helps me to prove that the two triangles are congruent. If I don't know anything about the angles, this is good enough, okay? Side, side, side is one of the postulates we can use. Side, angle, side would be a side, an angle, and then a side, okay? That's going to be congruent to the other side. When it is ASA, angle, and it doesn't matter which angle you pick, a side and an angle. So this is 2 lines. An angle, a side, and another angle. Okay, try to use the mouse for this. That's why it's kind of giving me. Alright, so this is what I was trying to do. Alright, when I have angle, side, angle, and the other one would be AAS. Angle, angle, side. So it can be this angle congruent to this angle. This angle here can be congruent to this angle. And then they have a side that is congruent to each other. And HL only works if you see a right triangle. That means the hypotenuse is given to be congruent, and any of the legs. It can be this leg congruent to this one. That's what and then we're going to talk about each of them in detail, okay? But one thing that I want you guys to remember is if it's given in this way, triangle ABC is congruent to DEF, then the corresponding parts, that means angle A is going to be congruent to angle D. It's the same thing we did earlier. Angle B is congruent to angle E. Angle C is going to be congruent to angle F, right? The same thing with the side. AB is congruent to DE. BC is congruent to EF. And then AC is congruent to AC is congruent to DF. Okay, so you just have to be careful. Okay, so make sure you also mark them if you need to. AB congruent to DE, BC is congruent to EF, and AC is congruent to DF. And then you can also mark the angles. Okay. So now let's go into the next day note, which is day 4. Okay. So I just want to combine day 3 and day 4 together. So day 4 is only going to focus on the two postulates or theorems that helps us to prove two triangles are congruent. One is side, side, side. The other one is side, angle, side. We know that triangles can be congruent if all corresponding side and all corresponding angle must be congruent, but mathematicians have proven that shortcuts that can be used to prove two triangles are congruent, and one of them is side, side, side. So what is side, side, side? If three sides of a triangle are congruent three sides of another triangle, then the two triangles are congruent. So what in this case is if AB, so the one that has 3 lines, right? AB is congruent to HR, yes, they both have the same line. If BC is congruent to BC is congruent to HT, right? And then AC is congruent to TR, then we can say, and every time you say the two sides are congruent, that is one side, this other side, so I have 3 sides congruent, then I can say the statement, okay, triangle ABC is going to be congruent to triangle HRAB, no, so this is another thing, I'm glad I'm running into this. So it went from A, B, which is 3, 1, 2. What I mean about it is this is 3 lines, right? This is 1 line, this is 2 lines. So I started with the one that has 3 check marks, or this tick mark. So 3, 1, 2. And that's what I have to go. Because initially I started from HR, but if I go this way, I'm going from 3, 2, but it goes from 3, 1. So I have to start from this way. So I have to start from R, right? So we're starting from R. So we're starting from R, H, right? That's RH. Then one side would be T, and then so be 3, 1, 2. Okay, so that's also important. When you name it, when the angles are given, it's easy because you can just write the corresponding parts. But when the angle is not given, then it gets a little bit difficult. Okay, so the second part is when we have to prove the two triangles are congruent. So the question is prove that ABD is congruent to triangle CDB. Okay, that's what they want us to do, right? So in this case, so remember when we start proofs, a lot of times they would be given. In this case, they didn't write anything given, but they gave you the marking, right? That is also can be considered as given. So in this case, I can say, oh, in this picture, I can see that AB, right? AB is congruent to CD. Is congruent to CD. And how did I know that? It's given on the picture, right? And then I can say AB, or AD, sorry guys. AD is congruent to BC. That is also given. Okay. Now, this middle line right here, that's the one, they didn't say anything about it, but can I say this? BD is congruent to BD. Yes, by reflexive property. So we're looking into our properties, and by reflexive, if you look at yourself in the mirror, you look at yourself, that's the same person, right? So that's what it is. So this represents a side, this represents a side, this represents a side. Then what I'm trying to prove here, I can say, oh, triangle ABD is congruent to triangle CDB by side, side, side. Okay? And that's what you guys have to do. So you write down what is given and additional information we have, and then you can say the two triangles are congruent by side, side, side. All right, so one thing we need to do is to recall if A is included between B, A, and AC. So angle A is being created by AB here, right? And AC here. That's what included means, right? And RS, the line RS, is between the two angles, between R and S. And this is something we did in the day 2 video, okay? So the last page for today, and the second postulate we're going to be using is side, angle, side. And that's why it's important for us to know what is included, because as you can see, A is between the two given side, right? So in this case, if two side and an included angle, this is very key, of one triangle are congruent two side and the included angle of a second triangle, then the two triangles are going to be congruent. So in this case, I have MN. N is congruent to RT. Okay, that's my side. And I have angle N congruent to angle T. That's an angle. And then I have NL congruent to TS. That's the side, right? Because it's given side, angle, side, I can say the two triangles are congruent, which is triangle MLN, MLN. So start with the one that doesn't have any line, and then with one line, two line. So I have to do it this way. One line, right? No line. Then one line, two lines. So I have to do it. M is going to be congruent to R, S, C. And that's something you guys have to be careful, okay? Alright, so that's what we have. By side, angle, side is what the postulate is going to be. Alright, the next proof is, this is where everything is going to start piling up together, okay? So in this case, nothing is given as a statement, right? But we can look at it from the picture and decide. So I know that HI, right? HI is given to be congruent to KJ. It's given, right? It's in that picture. Okay. And also I know IJ. Well, let's do this. So what is another thing that is given? HI is parallel to KJ. And how do I know they're parallel? You see the arrow they gave you here? It shows that the two lines are parallel. That's also given. So most of the time they gave you something for a reason. So they told us this is parallel because we can use what we learned in Unit 3. So I can say that angle HIJ is congruent to angle KJI by what type of angle are these two? Okay, some of you got it. Alternate interior angle theorem, right? Alternate interior angles. If two lines are parallel, then the alternate interior angles are the same, are congruent. Then I can add IJ is congruent to IJ, well, with what? Reflexive property. Okay, then I can say triangle HIJ is congruent to KJI by side, angle, side. Okay, that's it. So this is what we're going to be doing in class. So I need you guys to try this piece. So at least you should be able to write this part. KLM is congruent to what? By what? So remember, if all the sides are given, and when something is not given like this, you can take it. This is the rule we learned in Unit 1. So try to remember that and apply. If it's not enough information, just say not enough information. But since I promised everything would be not more than 20, I'm going to stop now.